Scale drawings are an essential tool in the realm of physics, particularly when it comes to understanding forces and their interactions. Imagine you're faced with a complex problem involving multiple forces acting on an object. It can be overwhelming, but this is where scale drawings come into play. They simplify the situation by allowing us to represent forces visually, making it easier to analyze and resolve them. A scale drawing is essentially a graphical representation where distances and angles are proportionally reduced or enlarged based on a specific scale. This means that we can accurately depict the magnitude and direction of forces acting on an object without needing to physically manipulate it. When we talk about resultant forces, we're referring to the single force that has the same effect as the combined effect of all individual forces acting on an object. To find this resultant force using a scale drawing, we first represent each force as a vector. Each vector is drawn to scale, meaning its length corresponds to the magnitude of the force, and the direction is indicated by the angle at which it is drawn. Once we have all the forces represented, we can use the head-to-tail method to combine them. This involves placing the tail of the second vector at the head of the first and so on, until all vectors are connected. The resultant force is then represented by a vector drawn from the tail of the first vector to the head of the last vector. This graphical method not only provides a clear visual representation, but also allows us to easily calculate the resultant force's magnitude and direction. Now let's delve deeper into the concept of equilibrium. An object is said to be in equilibrium when the net force acting on it is zero. This means that all the forces cancel each other out, creating a state of balance. When forces are balanced, they do not cause any change in the motion of the object, whether it's at rest or moving at a constant velocity. This is crucial in engineering and construction, where maintaining equilibrium is necessary for stability. In practical terms, if you were to draw a scale diagram of the forces acting on a stationary object, you would find that the vectors, when added together, form a closed shape, indicating that the forces are balanced. This visual confirmation reinforces the concept of equilibrium and helps us understand how different forces interact. Moreover, splitting a force into components is another vital aspect of analyzing forces. Forces can be complex, acting at various angles, but we can simplify them by breaking them down into their horizontal and vertical components. This is particularly useful in physics because it allows us to analyze each component separately. For instance, if you have a force acting at an angle, you can use trigonometric functions to determine its horizontal and vertical components. The horizontal component can be found using the cosine function, while the vertical component can be found using the sine function. Once we have these components, we can treat them as independent forces acting on the object, making it easier to calculate the resultant force and determine if the object is in equilibrium. In summary, scale drawings are invaluable in the study of forces. They provide a clear and organized method for resolving forces, calculating resultant forces, and understanding equilibrium. By visually representing forces and their components, we can simplify complex problems and gain a deeper understanding of how forces interact. Whether you're an engineer designing a structure, a physicist studying motion, or simply a student learning about forces, mastering the use of scale drawings will enhance your ability to analyze and solve problems effectively. The beauty of this approach lies in its simplicity and clarity, allowing us to visualize the invisible forces that govern our physical world.